Sure. So hi, my name is David Dickman, and I'm currently Vice President of Product Marketing at Cloudera. Cloudera has been in the AI business for over a decade, and I do a lot of working with our customers to better understand their needs, their requirements, what they're doing, and how we can best help.
Hi there, I'm Gopi Balsingh. I'm the Chief Architect and Head of Engineering for Manulife, and I essentially deal with the Canadian segment and the Canadian markets. So, thank you.
So if you'd like to take your seats, we'll start with the questions. So since we've lost a panelist, some of the questions may have to change on the fly as we adapt to, because we had some specialist questions aimed for Mahia. So AI is generating enormous enthusiasm and enormous spend. Let's start with the gap between those two things. What's the common mistake you are seeing in organizations make right now as they try and scale AI, and why does it keep happening? I'll ask OP first.
Well, that's a fantastic question, because what I see right now is that a lot of the organizations, they're kind of going from experimentation to trying to scale AI. And oftentimes, there's always a false sense of success when you see a pilot actually work, and then the hope is that you take it as is and try to productionize it. So what we're finding is that without having all the guardrails, the data quality, because AI without data means, it's going to hallucinate like crazy, right? Especially when you're in a regulated industry as I am, the ability for us to productionize our AI has to go through, I would say, a fairly rigorous cycle, because defensibility is huge. So any decisions, any actions that it takes, we need to be able to figure out the lineage and be able to explain that. So in summary, the way I see it, it's more like, AI models, they don't fail at inference, they fail at integration.
That's a good answer. David?
No, and I think to add to what Gopi has said, one of the things that we're seeing as well is choosing the right use cases and also choosing the right AI to fit those use cases. We talk a lot about fit for purpose. We see a lot of folks racing through and even finding ways to make things like generative AI and large language models solve math problems. And I often find myself in some of these talks saying, well, why don't you just do the math? Why are you using AI to do something you could just do directly? So taking a close look at what use cases you're choosing and where that business value comes from and using the right AI for those seems to be a common mistake that we're seeing, sort of rushing to that finish line and using the most expensive tool possible to solve the simpler problems, and then also making sure that when you do move that into production, that you've put the right guardrails in place to ensure that, not just that the right inputs and outputs are producing something defensible and usable, but that you're also making sure that you're not running up those AI bills to the point where the business is going to look at it and say, gee, can I ask this any more questions? Can I afford to use my AI further to get the business value? Dialing that in so that the positive return on investment actually comes to fruition.
That's a good answer. I think it's... AI is a lovely sledgehammer we have, but not everything is a walnut, and not everything needs to be broken by it. So when we're using AI, we've got cloud spend, we have the infrastructure costs, we have new token usage. It's becoming a bill shock. You're going to get the bill at the end of the month. You're thinking, how the heck did I spend all those things? Organizations are burning tokens on workflows, and they can't demonstrate the right business outcomes. How do you think about token economics as an architectural constraint? And what does good governance of AI consumption actually look like? So it's a two-part question. So, David, I'll ask you to keep going.
Sure. So the first part of what we're seeing, and a lot of this has to do with a lot of folks' newness to using AI, is the techniques and capabilities available to us to optimize how we put AI into production aren't as well known across the industry as they could be. So the temptation is to take that really, really large, super powerful large language model hosted in the cloud and just use it, but then also throw everything you've got at it. So there's a couple of places where we can find ourselves optimizing. We can optimize on the models themselves. We can also optimize on how we ask those questions and reduce that surface area of context that's passed with those questions to really only send what's needed to be sent and not just everything, because that worked in experimentation and gave some great results, but at scale is going to lead to those massive amounts of wasted tokens that are very hard for you to go back after the fact and say, well, where did that waste come from? Which tokens did I need or not need? You need to do some upfront homework for that. But one of the other things that we're finding is you don't always have to run those big, massive models in public cloud, that you can also choose to run your own models in cloud infrastructure or even run your own models in the data center. There's a lot of other opportunities for you to get those optimizations that can even take you completely out of the tokenomics game.
And Gopi?
So I'll take some concrete examples of how we're addressing this problem right now as we speak. There's no, I would say, secret that everyone wants to run to the frontier model. It's big, the best, all that stuff. But in the last 2 weeks, there's been a sticker shocker for all of us. Opus with Claude and the shenanigans they've been up to with the way the pricing is going. It's not quite working out for us because it's breaking all our business case as we speak. So we took a step back and said, hey, this is going to happen as the industry consolidates, and you're going to only have a few big players out there, right? So the concept that we came up, which is actually going for patents as well, is a model router. Now you might be like, okay, what does that really mean? So I'll just piggyback off your comment, David, right? A summarization of email, you do not need a frontier model. Whoever says that, they're dead wrong, right? I'll be honest with you. So then the question comes back is that, do we ask the end user to select the model? Then we start getting the debate, so, well, you know what? Human nature is, yeah, you give them a catalog of models. I'm going for the best and the biggest model. That's just human nature, right? It's not going to work. So hence, the model router concept comes into play where it in itself will figure out what the LLM call is and then route it to the right model. So there are two things that happen here, right? The first thing is that you're removing the friction point from the end user trying to determine what's the best model. The second part is that we own the routes as to which way we want to go, right? So we could pre-negotiate all our model providers, whoever it may be, and then based on the call as we intercept it, then we're going to be able to decide and go down that path, right? So there's that one. So that's actually working right now. It's been fantastic. The second part is how do we optimize token usage, right? I'm sure there's enough smart folks here. You're all reading lots of research papers and figuring things out. So we took the concept of a token notation, which is actually getting patented as we speak right now, because what we found is that there's a whole corpus of data that comes through. It's not the question that you're asking the LLM. It's always a 1 or 2 liners. It's a return that you get back is garbage, where you're just looking through, okay, the specificity what you're looking for is actually 10% in that rate, 10 to 15% of the output that the response to get back. So if you start looking at it, you're actually paying for 85% of junk data, and you're homing on the 15% of economics that you're really the ROI part. So now the question is, okay, how do we figure out to address that 85% that we're all trying to eliminate? So this whole, and again, there are lots of white papers. We looked at Tune. You guys go look it out. It's kind of interesting concept, where both on in and the out, it's a representation. So oddly enough, an area that I'm interested in is kind of going back to hieroglyphics, right? I'll be honest with you. A picture could represent 1,000 words. It's true. So that's one of the areas of research that we run. I don't have an answer yet. Hopefully soon.
That sounds like a fascinating approach. I'm actually a little bit more intrigued than I was earlier on this morning. So when we're doing this sort of token measurement, we're looking in, so I'm taking it slightly off topic now, but when we're doing this token appraisal for input-output tokens, how are you detecting the wastage on that answer that comes back? Is there a key metric, or is there some governance method or subskill or something you're using? And if you get into your patent, then just tell me.
Sure, I'll speak to an abstract. I did get clearance from my legal team, so I'm good. Observability is key, right? Because we don't, we do a lot of SRE best practices when it comes to cloud resources. The way I see it, the same lens should be applied for any type of LLM call or AI workloads, right? So to your point, once you start looking at the metrics in there, right, you start seeing a pattern. right? And I would say it all depends on the workloads you're after. If it's just text summarization, not a big deal. You could start looking at the length of data that's being sent, right? And then maybe you could strip things out and then focus only on the data of interest, and then make sure you send it across. And then what we found in certain instances, and I'll take a bit of a tangent, we're all using coding assistants. I'm sure everyone here is using that. What we found, this is the interesting part, is that the junior and intermediate engineers were getting lazy. Data proves it right now. Like, this is like me having a conversation with my chief AI officer literally last week on Thursday. And what we found is that it's easy. You're given an Opus model, 4.7 in this instance, and you're seeing an engineer with having a team that's actually not using critical thinking, just complete trial and error. And then what's happening is that the whole repo is going through, cycling many times. The same question or subsequent questions being asked, but they're in fact asking you to read the whole repo that they checked out. So in that instance, then it's an interesting view into the human nature as to how things are being used. There's a lot of wastage because the first time you read it, but the way the LLMs and these coding assistants actually work is that it's going back and reading the whole thing again and again, right? That's right there is just complete wastage right there. So there's no way you could change that. The only way to address that is through training. And then now the concept, well, you know what, maybe we shouldn't be getting this to junior engineers because you're asking for abuse of the tools as opposed to actually looking at for ROI. So I think at this point it's more of a trial and success. I hate to use the word error, trying to figure out what's the sweet spot. But this is a concrete experience that we're having right now.
And I love that you pinged on that, one of my favorite words, observability. When we look at organizations that are following best practices, and we see this, we know this from all of the traditional workloads we run. You observe, you monitor, you optimize in a continuous cycle. The challenge is with AI that we're finding, and especially LLMs and inferencing on LLMs, is there isn't always enough monitoring, there isn't always enough telemetry from that. So definitely as you're looking at these, find ways to ensure that you can, and find tools that'll help you, get that observability, get that monitoring in there so that you can do those iterative optimizations and look for where those trials and errors can give you hints on how you can actually do better and get those token economics in line, get those performances up to where they need to be to meet scale KPIs, and improve your whole AI game.
That's a good answer. I think it's actually fascinating. Nice segue, and I think it's worthwhile because it's brought us back onto track for regulatory industries, which is what I was trying to get back to. So what we're doing is and the regulation, we're trying to make sure that we can track and repeat what AI does. As most of you know, when you're using AI, you ask the same question, you're going to get a different answer. So what I'm going to do is throw the question out to both you two. How do you ensure that you can satisfy the needs of a regulatory industry while using AI when it's likely to give you a stochastically random answer? To quote Morton from LinkedIn earlier on.
Sure. So what we've been seeing, and so I've been working with some insurance companies, a lot of large banks, telecommunications companies, some of the most regulated industries in the world, and the big challenge is explainability. And repeatability seems to be one of the dimensions the regulators are harping on, which you can't guarantee that these inputs will always produce these outputs. So we start with first, these inputs. Are they the right inputs? And this goes back to that, get your data house in order. If you can show the correct lineage and provenance of the data, that data has been handled correctly, is sourced correctly, and is the right data as input into the models, well, that's the first half of the game. And that's something we've all had to do for regulatory requirements already. But then are the answers directionally consistent? So the example I like to give is, if I give you directions that say, go 1 block, turn left, go 1 block, turn right, go 1 block, or go 2 blocks, turn left, go 1 block. Different directions, right? But you end up in the exact same place. So if we have ways to analyze the output and can show that they are providing directional consistency, that they would lead to exactly the same decision, and in cases like healthcare would lead to the same prescription and patient directives, or in the case of banking and finance would lead to the same decisions on whether to take a risk or not take a risk, or in insurance, whether that assessment was measured the same way, no matter what the words around the assessment come out to be, then we can prove defensibility. But in doing so, we also have to do that in a well-contained environment, which means we have to be careful how many stages of LLMs are involved in a workflow, especially as we move to agentic, where each agent has to be defensible, explainable, and to a certain degree repeatable along the chain. So what we're seeing in practice is, while the promise of agentic is to have lots of little agents all working together and doing all these complex things, in highly regulated environments, having fewer agents working together, so you have fewer places where that surface area is exposed, the better you're able to meet those regulations today.
And Gopi, do you have an addition?
I do. So, interesting enough, I personally have to, what's the best word? Sign off on some of the OSCE type requests that comes to Manual Life, right? And AI right now, of those of you who deal with OSCE, AI, quantum, and emerging technologies are three areas that OSCE has a keen eye on, right? So one of the, I was speaking to David, to you, and explaining one of the patents that we patented almost 2 years ago was on straight-through processing, SDP, with intelligent document processing. That's kind of the holy grail in the financial service industry. Manulife probably does around 80 million-ish type of submissions, paper submissions, right? So we have a lot of document processing that needs to happen. And to your point, David, one of the things that we focus on is how do we try to get more of a deterministic result by orchestrating the whole thing autonomously by using statistical models, right? Stochastics, all the models were all there, all great. But at the end of the day, when the regulators come in, how do you know that this claim was in fact what you paid and there was nothing wrong with the claim, right? Which is a fairly, it's a great question. So and I prefer to use the example because I can explain to the audience as to how we approached it. Yes, we had the math, the statistics to prove that. But as we went through the whole cycle, it's also making sure it's defensible by showing that every step of the process, it's like a subway line, right? So every stop, there's a checks and balances. There's always some kind of spot checks or human reviews happening. So now, and this is key, right? Because any one of you, if you start looking at it, the human error rate is between 20 to 30%. We just don't advertise it, right? But that's the going rate. With AI, because it's so fast and we have a lot of it's not subjective now, right? You can actually start looking at the data points. It's less than 5%. So oddly enough, the regulators have no problems in the past when it was human errors, but now when machines are making errors, they seem to have a problem. So now it's the explainability to the auditors and whoever else comes through from all these regulatory bodies saying, this is what we have now, this is how we're doing now, right? So it is essentially standard deviation at the end of the day. We're just proving, hey, with human there were errors. There are errors here with machines, it's just a lot less than humans. That's the proof that we gave them.
That's actually a really good answer, and it goes into a project I did a few years ago where we were basically digitizing documents from 30, 40 years ago, old kind of industrial plant designs. We found we had a 95% accuracy on reading the document number from that document. That's all we needed was the document number and a picture of the image attached to the document number. A human did it. We used a human test where we did 1,000 with humans. They got 75 to 85% of those documents correctly documented. AI was up in the 95% mark. So we were able to prove, we did a whole lot of due diligence on the testing. We were able to flag that 5% that failed because we knew an indicator that would say it's likely to fail because of these things. So we could send those documents back for manual reassessment and rescanning if necessary, so we had a good way. AI is very powerful at finding those things. There's another case from radiology where if you get 15 radiologists in a room, they aren't going to agree on the diagnosis. AI is going to agree on a reasonable larger set than a set of radiologists. Doesn't mean it's more accurate. It just means it's good at determining certain factors. So as long as you choose the correct factors, you can then get this answer which is you want. Say, I can prove how I got to that point in this map.
I'll just add one more piece there. What's actually creating a bit of a buzz right now and helping us exactly in that area is reinforcement learning. Right? So because manual reviews do happen because of the failure rates, so how we're addressing and reducing that is through reinforcement learning. So now the learning mechanism starts kicking in and it starts looking at the failure rates, then it starts learning from those signals, and then as the inputs come in, it's able to identify this and say, okay, learned this in the past, I'm going to take a different route to address that. So now that 5% error rate is actually coming to sub 1.
And that's a good way of doing it, actually. I mean, we used all the technology at our advantage. It's not just LLMs. It's a whole ecosystem of beautiful tooling, expert systems, the old genetic algorithms, stuff like that we can use to solve these problems. If you bring all those skills in, we can build some very robust, repeatable, well, not repeatable, but explainable. I like that word, actually, for explainable. It's observable and explainable. Therefore, you can explain to someone else how you got to that answer, which is going to build up the trust in the system. So now what we're going to do is slightly segue to a democratizing of the data. So now we've got these AI systems in place. How do we open this up to the general people? So we want to democratize it. We want to democratize our AI. We want to democratize our data. So we've got non-engineers building apps, workflows and automations without thinking like engineers. So they don't realize. You lovely see those memes online. I vibe coded an AI, front end, back end, and that's it. You actually start understanding how it works. You understand all the little nuances, all the little layers, all the interactions between all those pieces that make it robust. Now, we're going to get security leaks if people vibe code. Where is the line that we need to draw? That we need to have guardrails baked in rather than bolted artifacts. So how do we enable people to vibe code, have ideas, turn them into effective artifacts and useful tools? But how do we put the governance in so they don't break our systems that we're working with? And whoever wants to take it first is...
I could take that. So this is the realities we're dealing with. Everybody under the sun wants to play with AI. They believe they're AI engineers, scientists, you name it, right? Which is fantastic. We want to democratize that. What we do not want to do is make the same mistake that we've made with data, right? Because once we democratize data, it started becoming chaos. I'm sure all of you could go from Excel macros to Access databases to everything else in between, and now we're trying to put everything to the lake, right? That's a cycle of events that took place. So once it comes to AI, we're actually giving a very powerful tool in the hands of end users. The approach that we took, and again, this is what I think Manulife did a fantastic job with our chief AI officer. He said, no, we want to build a global AI platform that's going to innovate at the edges and then bring all the guardrails and the controls at the center. So this way, all of institutional knowledge, right, our risk management, our controls, is all baked in, and you get that as a part of the platform that you would leverage. Then we open it up to end-user computing from citizen-led development. So, you know what? You want to use Copilot? No problem. Tag on and use the agents on a global AI platform, and you get all the guardrails in there, right? So this way, which is kind of interesting, because now it opens up the business units to be self-sufficient, and they're not running around trying to speak to IT or speak to the security teams and legal, compliance, everything else, because the data that you want to access, which is fantastic now, MCP, ACP, it opens up all the toolings for us with the guardrails, so that data access is governed at the center, and then these tools that are exposed to your Ferry platform that you want to use only gives you access to them based on the persona that you are, right? So that's how we have actually, I would say, our approach to it. And you could read a lot of news articles. We are betting on $1 billion in savings and so forth. Yeah, so we'll achieve that.
So if any ideas, go talk to Gopi and he can help with problem solving.
What's interesting is I'm sort of tying the last question to this question as well. One of the things that we keep seeing as a theme when it comes to the use of AI is it comes down to 3 key dimensions. Trust. Do you trust it or not? Risk. What's the risk of trusting it and being wrong? And consequence, what happens when it is wrong? And when we look across those things, it's funny. There's a lot of places where we have non-deterministic questions, where AI generates really good guesses or non-deterministic answers for us. And we actually we're working with a charity called Rare Hopes, and what they're doing is they're using life sciences data, and they're looking at rare diseases, and they're matching existing medications with off-label uses that can be used to treat rare diseases. The pharmaceutical companies can't do this because of their high regulation. They can't recommend or sell a medication to be used by doctors for an off-label use. They get in trouble for that. But the doctors can prescribe it, so they publish all of these guesses, these hypotheses for treatments of rare diseases in an open source library, that doctors around the world, when they're faced with these rare diseases, are finding that these hypotheses lead them to think different and are leading to better patient outcomes. Are they finding a cure? No. Are they always getting the right, best, perfect, absolute, no doubt best answer? No, but they're making better guesses than the doctors do. But what's funny is our tolerance on guesses from people versus guesses from machines is, as you're saying, oh, you're 80% good, I trust the person. Only 95%, I don't trust the AI. So there we're also measuring risk. What is the risk we're applying here? If I'm better off taking the AI's guess as a patient receiving care for rare disease, I will accept that risk because my outcome has a likelihood of being better. I might end up worse. There's a chance, right? But the chances, I'm weighing the risk. But then when we talk about things like some of the stuff that we do where AI must provide answers that are really solid and really directional, or people can be hurt. If stoplights stop working correctly, people can get hurt. Then the consequence of failing to be right, regardless of that risk factor, the consequences can be high or low. So we can tolerate different risk levels if the consequences of being wrong aren't so high or so low. So when we look across the spectrum and we think, what is this AI for? Are we using it the right way, and are we building in the right trust? Are we understanding the risk, and do we accept the consequences? I think we'll free ourselves to use AI in more places where that risk barriers and consequence barriers are lower, but add a lot more governance and a lot more scrutiny where those risk barriers and those consequences are significantly higher. And I think when we look at across how we use AI, if we look at with those dimensions, we can be more free to democratize AI in more use cases where those dimensions are low, and be much more guarded and careful where those dimensions are high.
That's a good point. I think so what we're revealing here is that we've got this element that AI can be more accurate than humans and can detect certain things that we are not able to pattern recognize, except for years and years of training. If you look at something like medical, where we're scanning for type 4 lymph node, I have a lesion on my foot that is actually a type 4 false positive for type 4 lymphoma. So every time I have a biopsy of my foot, I have to take 4 or 5 samples, and they get sent to various cancer institutes around Canada, so they can use them and say, this is a true negative. It's not type 4, but it looks like type 4. So they use my skin to prove and test the system. There are a group of people who are trying to put an AI on that to learn from that as well. So there's some fascinating ways that hopefully we will have more accurate tells, more accurate systems that can highlight where we should be going, the pathway we should be taking, establishing that trust over time, establishing what are the risks for trusting that AI, and then making sure that the consequences of making a mistake are minimized to the best extent. So it gives us a really nice way of building this stuff out. So since we've only got about 6 minutes left, what I was going to actually go into the AI strategy that was released last week, but I think we'll stay out of that one because I've had a discussion this morning for about 2 hours on that already, so I think we'll leave that one out. What I want to do is get on to, it's a nice little thing, is what is one architecture or AI investment decision that organizations are making right now that they're going to regret in 3 years' time? So where do you think the mistakes are going?
Well, and we're already starting to see some of that regret coming into some of the leaders who are on the leading edge of the curve. The big thing that we're seeing is banking your AI strategy on a handful or a singular cloud-hosted, foundational, massive, large language model, frontier model, banking on that, making your fine-tuning investments in that arena, and then once you move these things into productive capacity where the scale introduces new complex and unpredictable costs. You know, even today we see when inferencing with some of these models in the cloud, you get tier pricing, which unlike volume discounting, the more you use, the less you pay per unit. All of a sudden, the more you use, the more you pay per unit because you've hit a new tier, And some of that will be solved when capacity catches up with demand. But in the short run, what we're finding is, oh, geez, that's not a good place for me to run that model. I can't predict the cost. I can't ensure business positive return on investment. Let me take my model and go somewhere else. And you can't take that investment you made in fine-tuning with you. It's bound to that model. So what we're seeing a lot of organizations who are starting to see that early on doing is trying to take control over the models themselves, find a more variety in models, even take open or closed source models and inferencing them in their own infrastructure with their own inferencing services to be able to get control over that and have that portability. I can take this and move it around. I can move it to this cloud, to that cloud, back to my data center as I wish to keep up with the shifting sands of how these ecosystems are still in flux. So I think what we'll see folks regret in 3 or 4 years is marrying and then being really devoted to these cloud environments that may not be as flexible as they need them to be as they roll these AIs out at scale and into production to their customers and to their internal users. Some of these tens of thousands to hundreds of thousands of continuous connections.
Okay, and Gopi?
I could relate to that. It's quite near and dear to me. So we really have an issue with GPUs. So I'm not sure who here is running into AI at scale. I ran into the issue where we're doing claims processing, and at one point, Azure just fell over. And the reason was that the capacity in the Canadian regions, and we can't route traffic, being who we are, to any other parts of the world. We literally ran into GPU constraints. Well, not us, in this case, Microsoft did. And they're like, there's only so much we could do. You're given X, you're just bursting, and we just can't let you do that, right? So now the issue is, it's exactly what you said, David. We can't run to AWS or anywhere else because they just don't have the same OpenAI models, right? We pegged ourselves to 4.1, or 4, I think, 4.0, right? No one else. And we can't go direct. That's completely against our data governance layers. So this is a real issue. So we didn't have a fallback. Our fallback was, Philippines, hire up another 200-300 workers and manually start adjudicating the claims. This is a true statement, right? So when you take a step back, say, okay, you know what? We cannot pin ourselves to a cloud provider because there's only so much GPUs to go around. It is what it is, right? There is a constraint that we can't solve. So the way we start looking at it is like exactly what Dave, you're going. Small language models, right? SLMs are big for us right now, going forward, which is where I said that whole global AI platform is predicated on reinforcement learning with SLM. So this way, we could take a base model, an open weight model, whichever it may be, and from there onwards, we could build upon it to our institutional knowledge. We don't need the fancy, frontier models, which was great to start off with, which worked fine. But we don't need all the fancy multimodal stuff that it brings in. What we needed is to build upon it through a reinforcement engine and build that knowledge base that we're looking after. So this way, we're not tied to any specific cloud provider. We could spray across many. We got full DR. We satisfy our suite. We're all good.
Well, thank you both for those lovely thoughts and answers. I asked the questions, you gave me the answers. Any questions from the audience? Anybody want to talk? Or anybody want to ask a question? I can't see anybody around. Oh, we got over there. A fellow Vancouverite.
Yeah, it's a fellow Vancouverite, Fahim here. You started the conversation talking about how, we're challenged with behavior and people maybe burning your tokens or giving it out to your citizen developers and your business users and studying their behavior and understanding guardrails around it. So I feel like that question that I asked earlier, which unfortunately wasn't actually answered, maybe you guys could answer it for me, is it seems like this is really just a people process problem at the front end. Maturity notwithstanding on technology, you have to have the skill and the capability, the observability requirements, all of that stuff that isn't commoditized yet, and you need the competency and the capability to run it and operate it. That's great, but it seems like this is really about how do we teach people, business or developer, to do the right business system, the processes that we need to operationalize AI, and by proxy data. You said we made mistakes in data. You're fixing it on one end, but it's because of the systems and the processes that you teach before you deploy. Is that basically where we're at here, if I tried to take this to an elevator pitch?
No, we're not. I personally am not putting that level of thought process onto the end users.
Yeah.
We're completely abstracting that, right? Which will explain with the global AI platform, giving all the guardrails and everything else in between now. So I'm going to use the citizen-led development. We're big on that, right? And the good thing is that a lot of the, the tool providers, whether it's the Microsoft of the world, from you name it, Atlassian, everyone's kind of opening up their specs through either MCP or ACP. That actually provides us an opportunity now, right? So if you start looking at an end user, if you want to speak to okay, here's a good one. Mainframes are not going anywhere as much as we think it's going. It's not, right? We're all here to try different, angles to connect to the mainframe, and now the biggest thing is dump all the data into the lakes and go crazy. Fantastic. It does not give you real time, right? So what we are patenting as we speak right now is the ability for us to speak to the mainframe in real time in an agentic manner. Now, we expose all that to the end user, so the front office workers, there's front office, middle office, back office, right? So the back office is fine. The front and middle want to have access to the mainframe because that's where everything sits. The good thing is we can now orchestrate that through Copilot.
Yeah.
Right? And they don't have to think twice. As I mentioned earlier, the personas will define what access you have to the data.
So you're building that into the platform.
We're
All
building
of that
everything for the
layer
platform.
is in the platform.
Exactly.
Okay.
We cracked that nut.
So, David, do you want to give a very quick answer?
I'll just summarize what Gopi said. It's which people, which processes. End users will never pick models. But those who are helping implement and make the AI efficient, yes, like all new technologies, the failure to use them effectively ultimately ends up being a people and trainings problem. So sophisticated systems like what Gopi is creating here are designed to be able to help those end users have a good experience because one was built for them to work. So those who are the builders on that, they are the ones that definitely need to understand what makes good AI, effective AI, and get that positive return on investment.
Well, thank you very much. I think we'll actually call it quits now for the thing. So would you like to thank David and Gopi for their lovely, profound answers? And if you want to talk to us afterwards, we're welcome to come and chat to all three of us. So thank you very much.
Thank you.